Okay, good evening, everybody. I'm quite amazed at the turnout. It's frightening. I'm not used to speaking in front of so many people, so I'll keep it sweet and short. It gives me great pleasure to introduce John Mendelson and Chris Hines, both of whom are apparently rock stars, otherwise there wouldn't be so many people here. And they're going to tell us about, looks like ducks. Over to you, gentlemen.
John, would you like to say a few words? All right. Okay, folks, we have a time constraint, so let's get on with it. Can you hear me through the mic? Okay. This is a story that started a long time ago, and I just want to warn you that the gestation period of this particular project was probably outside of all parameters of any project you've ever heard of. But I was very lucky in the early 1980s to be stationed. I was the first biologist for the northeastern part of Namibia to be stationed in Tsumkwe, or outside of Tsumkwe. And when I arrived there, I had no appreciation of what I was getting myself into. I lived in a small camp outside of Tsumkwe, and I had no idea that the system that we were looking at there in the middle of the Kalahari was a massive wetland system. When that system fills up with water, and I understand that it's full right now, it goes from being something like this, all right, to, when you've got a little bit of rain, something like that. And there are a few ducks there, and I was pretty excited by this all. And that was about the sum of my first year there. It didn't blow my mind or cook my goose or whatever it was. It was a really exciting time for me as a young biologist. I was doing vegetation studies up there, but I had a little distraction in birds. And then in my second year there, it started looking a little like this. These very extensive woodlands in that part of the world actually got flooded. And the whole area was under about a meter of water, and it goes on forever. And by my rough estimate, we're looking at about 100 to 120,000 hectares of wetlands suddenly pop up in the middle of the Kalahari in a sort of pretty unannounced way. I was blown away by this whole thing. And then really huge numbers of birds started pouring in. And all these birds just came in to feed because of a superabundance of food. And it looked like this day in and day out. And this happened a number of times in the years that I was there. Fortunately, John was part of the museum at the time. In those days, we wrote letters to each other. And I said, gee, guys, there are birds around here. And then 3 weeks later, I'd get a reply to say, yes, we're coming for a visit. And they'd arrive the next day. But we were really blown away by the huge numbers of birds there. And then we quickly realized that it wasn't just the Nai system that was functioning like this. Other areas, for example, in the Machadichadi, at the upper end of the Machadichadi on the Nata River there, huge numbers of birds were piling into that area and breeding in very large numbers as well. And we were very lucky in that we started finding what we considered very exciting birds at the time because they weren't really known from our previous experience. And they were very poorly documented as to where they were and what they were doing there. So things like African crake were abundant at certain times of the year, and we found lots and lots of nests. Things like striped crake were popping up and breeding. And in the book at the time, Roberts was a great big fat volume, and there were about 3 lines written about striped crakes because nobody knew anything about them. And then more tropical species, such as lesser moorhen, also popped up, and they were there in very large numbers. And we started asking questions about what was going on. And across all of these systems, lots and lots and lots of these birds of various species. For example, dwarf bittern, a small bittern that Bitterns are known largely from perennial wetland systems, and you don't really expect them out there, but breeding in large numbers. Allen's gallinule was another tropical species that we were blown away by with the large numbers of the birds arriving and breeding like crazy. Painted snipe. I'm just whipping through some of these pictures to give you an idea of the fantastic array of birds that we suddenly found in these systems. And we then also started finding things like large numbers of wattled cranes. This isn't in Nainai, but I saw on the bird group the other day that Christo Snowman found, I think, 23 wattled cranes in Nainai. That tells me that that system is connected to some other system because they're not there when it's dry. Okay, and we started thinking about these questions. And then some really amazing things happened. Huge numbers of open-billed storks and glossy ibis suddenly turned up and all started breeding in the trees in these flooded areas. Hundreds and hundreds and hundreds of nests across the whole landscape. Things like whiskered terns would suddenly arrive as soon as the grass was a certain height and they were able to build nests. They settled in, built nests, and bred in large numbers. And then we had the more prosaic things like red-billed teal, which were, again, popping up. And I remember once finding red-billed teal within 24 hours of a major rainstorm. There were lots of red-billed teal on those pans. The question came, how did they know? Where were they coming from? And did I miss all the pans that were nearby that they were hanging out on and they just moved so that I could find them? But no, we couldn't answer any of these questions. And then we started seeing things like black-necked grebes. Black-necked grebes winter largely on saline systems along the coastal areas of southern Africa. We don't see them inland, or if they are inland, they're on salty systems. But they don't breed on those systems. And all of a sudden, they turned up in very large numbers in Nainai and started breeding like crazy. They were actually nest pirates. They would just put their nest on top of the whiskered tern nest, wouldn't even throw the whiskered tern eggs out, just put their nest on top of the whiskered tern nests, and off they went. We also started getting large numbers of flamingos. These are coastal species turning up inland. How did they know? It wasn't, you might argue that the birds coming in from things like red-billed teal, they saw the rain going past and then they followed along afterwards. But the rain never got to the coast. But the birds turned up inland. The question was, how did they know? And how did they get there? Was it random? Was it more defined? The other thing we noticed in these systems, and this is not just in Nainai, but in these other systems, they were very, very important wintering areas for migrants from the northern hemisphere. Very large numbers. This is mostly rough. Would turn up on these systems, and you would see lots and lots of stuff. And so over many, many years of spending time around a fire, John, this is you now, you're up, okay? And we discovered that, these things are not supposed to do that. Anyway, we discovered that science is better with a fire and a glass of red wine. Okay, and we came up with bigger and better questions.
Yeah, thank you, Chris, and good evening. Chris, do you need to press? Yes, go for it. Okay, yeah. Anyway, good evening. Yeah, this is a good place to start. Just to maybe reflect a little bit on that history that Chris was talking about. This does really go back 40 years. That Chris and I and several other people, I think our first trip to Bushmanland to see you was probably 40 years ago or so, and Roger Swart in the back there, I think he was along, and John Ward and others. And what's been interesting is that over the last 40 years, we've just been marveling at the sorts of things that Chris has described, things that we've seen and we've seen described elsewhere in other parts of Africa. And all I guess we've really managed to do in all of that time is to think of some fairly substantial questions and refine those here and there. And these are questions that just don't go away. As Chris said, how do birds know that it's rained several hundred miles away? And there are other elements that we can talk a bit about it. But where are these birds? Where have they been before? Where do they come from? How do they connect to populations of the same species elsewhere in Africa? And where are these ephemeral wetlands that are, such as those in Bushmanland, that are so important? Sorry? Oh, I see. Okay. On the screen. Okay, yeah. So how do they know where to go? That's a really important fundamental question. You need to bear in mind that, as we well know in this part of the world, it doesn't rain that often. So when it does rain and there's water and there's food to get, you've got to hurry and get to where you need to be. I missed one there. At any rate, if we look at where some of these major ephemeral wetlands are in southern Africa, you see they're fairly widely spaced. Some of the biggest ones that we have in Namibia, in Etosha, and the wetlands north of the Pan and around the Pan, Nai, Bushmanland, and then a number of others scattered around that are labeled here. We need to bear in mind that these are major ephemeral wetlands where tens of thousands of birds of many, many different species breed occasionally, and obviously from a conservation point of view, they're really important and we need to know where they are. But bear in mind that in this map there are also hundreds and thousands of other little pans. I'm sure you've seen them on farms here. You'll walk through the grass, come across a little pan, and a dwarf bittern or a lesser moorhen will get up. And so there are lots of other little wetlands that birds respond to and hone into, in addition to these big ones that we have mapped here. So I think you're on now, eh? Yeah. All right, yeah. So this is going to be an up and down show, as you can see, but...
All right, so we asked ourselves, why do these birds go to these temporary wetlands, these things that are dry for most of the time? So we have to do a little bit of science here now, all right? So we can define wetlands in three different ways. We can call them perennial, and by that we mean that there is always water in the system. And those systems are persistent and lasting. And we'll look at why these birds go onto these things in a minute. The other type of wetland that we know about are seasonal wetlands, and those are things that you might consider to be predictable. Sorry. So you have a wetland that occurs every single year at the same time, so it is roughly seasonal. Folks, these are not absolutely defined boundaries. I'm trying to give you some examples across a range. And then you have what we call ephemeral wetlands, and ephemeral wetlands are very important systems, and they are defined by being dry for most of the time. But when they fire up, they are pretty exciting systems, as we discovered. And we have to ask ourselves, what is it that the birds are getting out of these systems that are so good? Perennial systems, we knew, are also not sites of major breeding events of the birds that we were seeing having major breeding events in Bushmanland, Mahadi, parts of Zimbabwe, those sorts of things. We're seeing this as slightly different, and well, a different set of species. And we have to ask ourselves why this was happening like this. So being a botanist, and also I had training in limnology, I started looking at where's the nutrients, where's the yum yum, where's the nice ice cream in the system, what's attracting these birds to the area. So if we look at perennial systems, and this is a very simplistic nutrient and energy model here, okay? What you have is this got a pointer in it. There we go. So in generalized nutrient models and energy models, you have three major compartments. You have the soil and water. I put water there because we're dealing with wetland systems. All right, you usually have the soil, and you have the dead animal and plant material called the litter, and biomass. In perennial systems, what you've got to understand, and this is really critical in understanding why these things use these systems, is that the biomass is largely tied up in indigestible plant material. Many of you have been into big perennial swamps. Any of you have gone down the Zambezi or down into the Okavango Delta, messing around in those Phragmites reed beds. That stuff is not edible. Things like the cypress papyrus, the big papyrus stuff, it's not nice stuff to eat. And that stuff, it's a little like rainforests. The rainforests are productive systems because they have very fast nutrient cycling. But the vast majority of the nutrient is tied up in the plant material. And this is not available to things like fish. Well, limited amounts are available to fish and the small crustaceans that these birds like to eat, and algae and things like that. That's why you have nice clean water in the Okavango Delta, for example. They've taken the nutrients out of the system. So what happens is when there is some death in the biomass, it transfers into the litter quite quickly, rots because it's wet and it's very fast, goes up into the soil water thing, and is taken back up by the biomass very, very quickly. So there's not a lot of ice cream in the system. Okay? And the only birds that can really handle this well are the they are species that are not dependent on things like crustaceans and algae for their diet. Okay? And I'm being simplistic here, okay? So one of the things we saw, these are photographs from a young researcher called Jonah Gula from the the Zambezi River floodplain north of Mongu in Zambia. He discovered that open-bill storks breed there in huge numbers. Well, open-bill storks are snail specialists, and that's all they eat, okay? And so in years of superabundances of snails, all right, what defines that outbreak of snails, we don't know. They breed in very, very large numbers. And this is a ground level view of that colony, and this is the aerial view of that colony. Every single little black dot in this photograph is an open bill on a nest. He estimated 70,000 breeding pairs. That's a lot of snails, all right? And snails are plant eaters, and they are able to digest this largely indigestible stuff very easily, and then they provide this very abundant food for this breeding event. In ephemeral systems, the nutrient dynamics are very, very different. So what we find is that during the dry phase of the ephemeral systems, and just remember that this is the normal phase of the ephemeral system, everything is in the litter component. It's dry, folks. All the plants are dead. There's not much happening in there. And it just sits there, and there's not a lot of, because they are wetlands, there's not a lot of termite activity in the basins. So the turnover of those nutrients from the vegetation is very, very slow in terms of the litter turnover. And there's very little nutrient in the soil-water component because the water is absent, and there's some nutrient in the water. And the biomass is extremely small, okay, because everything is dead or dry. And there are some animals and plants there still persisting, but the vast majority of those things, it's non-productive system. When it's dry, life is not there. And as soon as you add water, all right, you instant life, just add water. What you do is you put moisture into the litter component. The little litter component decomposes extremely quickly because there are lots and lots of decomposers in that system, bacteria, algae, all those sorts of things. And they take up those nutrients, and then they are eaten in turn by these tiny little crustaceans and other macroinvertebrates that are there, and then they form, the nutrients go up into the water and they're suspended in the water body. And then those things are taken up very rapidly by the biomass. And this biomass, this is the avian equivalent of a teenager going into McDonald's, all right? It's just a superabundance of McFlurries and burgers and whatever you can eat for as long as you want, as long as you can keep going at it. Because you're talking about, and there's some it's actually quite dated research done in the Orange Free State, in the Western Orange Free State, and some of these ephemeral systems. We're talking about kilograms per cubic, about a kilogram per cubic meter of water of food in a thing, like these tiny little crustaceans and things. That's a lot of food. So there's these animals and plants provide the food and energy required for the birds to breed. Okay? There's this massive release of nutrients, and it really it fires up these systems, and that's why these birds are coming in. All right? So that's, I think, the end of the science lesson. John.
Perhaps just to add a couple of things onto what Chris was saying. What is clear also, the longer a system is dry, the more breakdown there is of all of this biomass and so on. So arguably, the longer an area is dry, the more there is that comes into production when it does get wet. So that's one really interesting thing. And the shorter the period of decomposition, the less there is in the way of food, when rain happens. One other thing I'd mention, Chris described the situation that he had in Bushmanland, and all these birds, it would rain, various birds would come in. Different birds come in at different times, because for birds that like cover, for example, there's no point in pitching up the day after it's rained because there's no cover. Other birds may require a particular kind of food that will only come into production a week or 2 weeks after it's rained. So the timing of these movements has to be really critical. It's not a matter of just saying, well, it's rained, let's go, because you're going to get there. And for many birds, there'll be nothing much that they can do. So just, we have no clue at all what sort of mechanisms are used by birds to anticipate conditions that will be suitable. The other thing I just wanted to mention before getting on to this is that in as much as we're describing a situation for wetland birds and ephemeral, a great number of migrants that come to this part of the world, the swifts and the swallows and the storks, in a sense, operate in exactly the same way. Following thunderstorms, following fronts, you've seen this year has been a bumper year. All sorts of birds have pitched up in places where they would never normally be. And they too are following these centers of production as it rains in a place. And again, if it's been dry in Kaokaveld for many years, when it rains, on average, it's going to be a much more productive area than another place that has had rain more regularly or frequently or more recently So there's very interesting elements of getting the timing right for these birds and so on. Just going to talk a little bit about movements now. Chris put up this taunt here is flying risky business. For those of you who fly, I don't know what your answer would be. But the point is that getting back to what I was saying, if you're going to go off on a huge mission 400 or 500 miles across the country to look for a wetland, there's a risk involved. You may get there and it may not be suitable. All the spaces may be taken up. And for us in our sort of, given the way, the slow pace with which we move, it's very hard to understand how a flamingo can jump out of the water at Walvis Bay and head up to Etosha. It seems like a really impressive, and it is an impressive movement. But you'll see later on that these birds, many of these birds can move exceptionally rapidly in very short, they can go long distances in fairly short times. And it leads one to think, in as much as honeybees communicate about where there's food for a honeybee colony, one starts to wonder if there aren't certain individuals in the flamingos down at Walvis Bay that are actually sent out there. It's quite possible. I mean, if honeybees can communicate along those lines, I'm not saying this is the case, but you'd have to wonder how does this information get around? So flying is risky business, but it happens in remarkable ways, and we'll share some of those examples. So these are pintails, and here's a real record holder. So these are pintails who nest down in Louisiana. They winter there, and then breed in eastern Russia. And they fly up there. This is the track of a bird that was tracked with a transmitter all the way up there. And then it came back here to California, and it did that this was a remarkable, let me get the numbers here. So its return journey over 3,500 kilometers took 25 hours. So some birds, really, really go at huge speeds, and they can go far. Just remind me about that godwit from Kamchatka.
A recent report out of the US. They have programmed banding and with satellite trackers bar-tailed godwits that breed in that eastern part of western part of Alaska. So up there where that long peninsula comes off Alaska,
There, yeah.
no, that's Russia.
There, yeah.
Anyway, they fly out of there directly down to New Zealand. Right? A bird was reported the other day in one of the journals. 17,000 kilometers
Just try to speak
in 19
directly into the
days.
mic.
Into the mic, okay.
Non-stop. Okay? The remarkable thing is that
So when they're giving
it's
comments,
established
they're
in
giving
history
comments and asking questions, you give them them.
Okay, yeah, yeah.
organism that's doing this every year in large numbers. And you've got to burn an incredible amount of energy to, essentially, to get that far.
Going back to some of the centers that we know about of where there are important ephemeral wetlands here. These circles here are drawn with their radius of 400 kilometers around Etosha Pan, around Bushmanland here, the Okavango Delta, and so on. So, 400 kilometers sounds a long way if you're going to fly, but if you bear in mind these sort of distances and the speeds with which birds can move, you start to imagine that they may indeed be doing quite a bit of cruising around in ways that so far we have no handle on at all. In terms of tracking methodologies and ways in which to track these birds, the main technique now these days is with a transmitter attached to, in this case, a spoonbill. And this is a spoonbill that was tracked between Zambezi up here, up into the Barotse floodplains, north of Mongu, and then came back down to the delta, first straight across the woodlands here, and then down here, and then back up into the eastern wetlands around Linyanti and Liambezi. And another example of an open bill stork, again spending a lot of time in the Barotse floodplain up here, making some rapid movements across the bush, so to speak, down to wetlands here, and then following wetlands along the Cylinder Spillway, Linyanti here, up the Kwanda River, and then going back up there. So at times just heading straight across the countryside, at other times following wetlands, presumably in a much slower way. Chris, back to your stories.
So we're looking at, we're seeing birds moving great distances, and we started asking questions about what else are these things doing that may indicate what adaptations they have. And I started scratching around looking at ducks around the world, and the vast majority of duck species are actually Northern Hemisphere species, okay? And then one of the things I noticed was that most of their ducks are dimorphic. The male is very different to the female. And it's like, okay, why? It was because they have very fancy breeding systems. The males have to display and have a territory, and they've got to do the whole yo baby thing. I've got a nice house, I've got food, I've got everything here for you. And I started asking why we don't have those. We are in these ephemeral systems. We don't see a lot of dimorphic species in the ephemeral systems. And then, so, thing like pygmy goose, all right, is not, it likes these seasonal pans that are very productive. It has a certain vegetation type to it and that sort of thing, but it's a hole nester. And the male is very different to the female. And all the dimorphic ducks in an African sense are specialist breeders, all right? And so they have, the male displays in a certain way, the female responds, they have pair bonding in a very defined way, and so it's different to what we're seeing in ephemeral systems. What we're seeing in ephemeral systems are things like red-billed teal, brown, not very exciting. Males don't look very different to females, and Cape teal are the same. And shovelers are slightly different, but they're not really. And so the vast majority of these species are not dimorphic. And when we start looking at some of the reports on how they breed, we notice that things like their reproductive strategies are a little more aggressive than these dimorphic species. These red-billed teal are just, they land on these pans, and I mean, within a week, we're finding lots and lots and lots of nests. That doesn't indicate any great display or pair bonding or anything like that. And we also know from research, actually from the 70s and 80s, that there's a whole ecology of forced copulation in African ducks, okay? If you're a female and you arrive in a gang of these boys, you're almost guaranteed to get raped, okay? They will attack her, and there is forced copulation between individuals. There's also forced copulation between individuals of different species. There are known hybrids between this and yellow-billed ducks, for example. So there's a whole different thing going on here. And we started asking other questions about this as well. And we realized that there were some other strategies going on. This is a red-billed teal. And that is 22 babies, right? There is no way that duck, that female, produced 22 eggs, right? All of the same size. That tells us that something else is going on. And we know it's going on because I and other people have actually sat and looked at nests, found nests, and you go back a couple of days later expecting another egg, all right? And there are 15 eggs in a nest, all right? So what you're doing, and it's a low-risk thing for birds in an ephemeral system, is that you're spreading the risk. You see that your neighbor, Jane, is off her nest right now, and you've got an egg in your oviduct. Well, why don't you just go and put it in Jane's nest? All right? They're parasites. These ducks are essentially parasitic, okay, because it's a way of spreading the risk between lots of different nests and different parts of the system. So you can then take off and go off to another part of the same system or another system, another big pan area, all right, and dump an egg in there and get somebody else to raise your kids, because energetically that's extremely low for you and it's a low risk thing. So we're starting to ask questions about these things, but we don't have the answers. We don't have any defined answers, but there's some interesting things going on. The other thing we're starting to realize is that there are some exceptions to the rule, and it might indicate that there are different systems and groups of ducks on the continent and within the sub-region. One of the birds that really stands out is the yellow-billed duck. This is a rare bird in Namibia, right? And when we look at the ringing recoveries, all right, lots and lots of them were ringed, and they all go east. This bird does not go west. And so and we do know some things about these eastern parts of southern Africa, is that there are temporary pan systems in some of them, and these things are utilizing those highly productive environments. So we're starting to think that there are other species, and fulvous duck might be one of them. These whistling ducks seem to be able to turn up anywhere and breed just about anywhere. They have a much broader distribution, but things like knob-billed duck does not really utilize the ephemeral systems, but are elsewhere. But the question arises, what do spur-winged geese do? Right? Spur-winged geese, we see huge numbers of them at some times, but do we know where they breed in large numbers? Because it's a very common duck in different areas. Anyway, there's so many questions that come up, we have no real answers, okay? So we come back to this whole thing of where do they come from? Where do they go? Where are they during these dry periods? What are they, why, we've got some idea of why they breed in these ephemeral systems, but we don't have the data for it yet. We've got a very good idea of how they work, all right? These regional populations are our populations connected to other populations in Africa. Jonah Gula, the young guy who did the spoonbill and the openbill work, put a tracking device on a great white egret on Lua Plains. Lua Plains last year dried up. It went onto the Zambezi for an extended period of time, and this bird then decided to go and try another part of the Lua Plains system and flew up into Kamea, which is in Angola, and it sat on the one river there for a while, and then it took off a mere 890 kilometers, and it is still sitting in the middle of the DRC. So we've got connectivity. So what's stopping our birds from going all the way into West Africa? So we need to know these things to understand how to manage and conserve these things. All right, John, it's your turn.
So you've heard us talking about questions and lots of puzzles. Chris and I are both getting on, and we just are trying to, well, physically, yeah, sure. You're ahead, but anyway. To us, these are really important questions that, humanity at large should have the answers to, and we're really keen to see some institution and students get involved. There are wonderful techniques now, as you see, to track animals around. Lots of satellite imagery, lots of remote sensing of weather conditions, and so the volume of data that you can bring to bear on answering some of these questions is really impressive. Broadly speaking, in terms of tracking the birds, there are two approaches, either ringing or more higher tech transmitters, satellite transmitters. This is a goose with a color ring. I was recently, last week or so, I was in the DRC, and we came across a village, some villages nearby had a bird which turned out to be an osprey, and this bird had a color ring and a metal ring from Belarus. Just how a bird from osprey from Belarus makes its way into the DRC is hard to imagine. But these, this just, again, you find this bird in the middle of nowhere, and it raises questions, and so many interesting questions at that. There are all sorts of new satellite tracking systems. The Icarus system has great promise. It's was been installed recently, but hopefully next year we have some collaboration with people at the Max Planck Institute, and the hope is to get some transmitters down here and put them onto birds. And this just gives you a quick view of some of the tracking studies that have been done. Chris mentioned these godwits going from Kamchatka to New Zealand. Here in Namibia, a lot of our birds come, in fact, from far Eastern Asia, from Japan, from China. Most of the European swifts that we have here come from China. Fascinating tracking of swifts nesting in Beijing. Cuckoos coming from China, European or common swallows. So a lot of birds, and you would think they would be going down into Australasia, but they, for some reason, come all the way southwest and down to us here. So lots of things that can be learnt. The transmitters are getting smaller and smaller. The battery systems are getting better and better, and these transmitters are solar powered, so you can have a transmitter going on a bird for 10 and more years, and just collecting an immense amount of data. So this is the kind of thing that we hope might be possible, and I think that's once we have these kinds of transmitters on red-billed teals and flamingos and lesser gallinules, all sorts of fascinating new information will be available. This just gives you an idea of the sort of the network of information that can be used and gathered from tracking the birds, and all sorts of biological information that can be assembled on the ground, and environmental data through remote sensing. So we can bring all of this information together, and this is the potential that we would really like to see exploited. These are some of the sorts of analyses that can come out, looking at relationships between biological variables and climate, and we can start to think about how distributions and movements may be affected by climate change in time to come. So, Chris, is this you or me? Let's see. Okay. Chris is good at finding an institution, so...
So, what do we need to get this going? Well, we need to find an institution because, as John alluded, some of us are getting on, and we can't. Well, yeah, I've got to talk in the microphone. So we can't accept, if we get any money in to do this work, we can't accept it as individuals. And right now we're trying to find a home for the project, and I'm very glad to see some nice young people here. We've got projects for you coming out of your ears. If you want a PhD, I'm sure we can dream one up. Just find the university to support the program. This has been an ongoing thing. There's a lot of interest in it, but nobody wants to take it on as a project. Long-term, my experience of discussing this is long-term data collection projects. Most universities are not that keen on it right now. All right. We also need to look at some focus projects to start getting data together to then develop the impetus to do more work and more work. We're hoping, yeah, we'll give you some ideas of that in a minute. And then we need to also find some funding. And just to give you an idea of some of the odd things that we could look at in terms of focus projects. Everybody knows this duck in Namibia. This is South African shell duck. And this has got to be one of the weirdest animals in the wetland systems, okay? It's an arid zone specialist. It does not like wetlands. It's an arid zone species. It breeds in these temporary wetlands in arid areas. And what makes it even weirder is that it has oriented itself in its breeding system in a very odd way. It breeds almost exclusively in aardvark burrows. Okay? So, given the paucity of data on aardvark and the lack of knowledge, all we need to do is to find aardvark, is to track a few of these, and we can find the aardvark. But it's just be a very, very interesting species to look at. We don't know what's happening in these arid areas in terms of loss of resources with climate change, for example. Are we looking at fewer and fewer birds actually surviving through the whole thing because there are fewer and fewer wetlands? We don't know, all right? The other thing we could look at quite easily, and I think this would be very interesting, is that different wetlands have different values to these birds, all right? For want of a better word, it's the values, okay? In this photograph, and this is from Lua Plains, there are virtually all those birds are fish-eating birds. And what that tells us is that this system doesn't have a lot of those little crustaceans that they like in other systems. So some of these ephemeral systems are fish-oriented systems. So the flood comes way out of Mozambique in here and brings vast quantities of fish down, and this provides a massive input of energy into these birds. But they don't breed here either. They fly back to the Zambezi and breed in the reed beds and that sort of thing. So this is you could start looking at what we call guild structures and why are different groups of birds on different types of wetlands, okay? What are the habitat choices that these birds are making? This is, again, Lua Plains, and this is the type of wetlands that you get there, and those white dots are pelicans. Huge numbers of pelicans there at certain times of the year. Fish eaters, and they are there to load up and they move out and breed elsewhere. There are no trees on the system in which to breed. Okay. Now, John, believe it or not, this is you. We had about 5 minutes.
All right, a couple of sort of take-home points I think we'd like to leave you with. Not all wetlands are equal. I think that's something that's really important. And again, it applies not only to wetlands, but to the sort of environment that we live in Namibia. If you're going to live in dry Namibia, as pretty well any plant or any animal, you really have two options. One is to be able to move very rapidly. move to places where it has rain, where food is available, where nesting opportunities, move there rapidly, get into the business of breeding as rapidly as you can to make hay while the sun shines, to use those nutrients. The other alternative is just to spend your life sleeping, either as an east-evading animal, or as an egg, or as a spore, or as just a moribund plant that is dormant. And so when you start to think of how animals and plants in these environments that are highly variable operate, it becomes clear that you can look across the desert landscape and it all looks fairly, uniform. But there are all sorts of things going on there at different time scales and different spatial scales. All right, okay, great, thanks. Okay, so we have variation in wetness. We have substantial variation, as Chris explained, in some detail, in various dimensions, as to the availability of nutrients and the functionality, what kinds of nutrients are available, in what package sizes, and so on. And again, just coming back to my earlier point, we need to think in terms of large spaces and long time frames. Things don't happen necessarily predictably, they don't happen at the same time of the year, and they happen in different ways in different places. So again, for animals and plants, and especially animals that can get around, there are lots of challenges that they must deal with. So these are the basic questions. I think we've been over them to some degree. Ephemeral systems offer refugia. It's really important from a conservation point of view that we know where these are, where the most important ones are. Sure. What do I do here? Somebody in the back there, can you sort that one out? Anyway, I can continue. There's a lot of variation in terms of the hydrology and the dynamics of the nutrients. There are all these big questions about how birds move. Where do they go? When do they go? At what stage do they turn around and go back to Walvis Bay, for example? And how do they make decisions about their breeding strategies, and so on. You've heard a lot about the parasitism that Chris spoke of earlier. Is often called egg dumping, but is really just a way of it's a form of parasitism, of maximizing your egg production and having other people do that work. And Chris spoke about different gill structures, fish-eating birds, crustaceans, vegetarians, and so on, and climate change and conservation management are important elements that come into the debate here. So we'll leave you with this laughing shot of a pink-backed pelican, and we will finally offer some gratitude to various people that have helped us in this pursuit, photographs and thoughts, and here are some of them that are listed. So I'll leave it at that. Chris will take all questions, and I will go home now.
Thank you, John. My kop is deur mekaar. Filled with a lot of stuff. Thank you for an excellent presentation. Are there any questions? Please explain the term guild structure.
Okay, this is a a bird biology. Oh, well, actually, it's an ecological term about animals, generally about animals that eat the same food in the same area, or species that occur in the same area. What do they do in terms of their grazing, feeding, whatever it is, in order to separate? How do they all survive in the same system? And it's just a way of looking at strategies that fish eaters look at, adopt. Yeah, I'm just trying to think of, I mean, it's separating and segregating different groups of animals as to how, usually it's animals. I can't think of anybody, as a plant ecologist, I've never used the term guild, all right? But it's usually about how do animals partition the resources in a particular area? How do they separate themselves out? Do you eat big fish, small fish, even smaller fish? You know, that sort of thing. Yeah, with tomato sauce, without. You know, it's like, one of the most famous guild structure studies was from the very early 1960s, early 60s, was Stewart's guild structure analysis of grazing animals in the Serengeti. Okay, and he asked the question, how can so many species be eating the same stuff? And it all had to do with bite size and what they like to eat. Did they like to eat the tops, the middle, the bottom? Did they eat lots of it at the same time, or were they little nibblers, all those sorts of things? He did a lot of detailed studies and was able to show that each one of those antelope species, he looked mostly at antelope, actually eat slightly different parts of those plants. There is some competition because there's got to be overlap, but they were able to they separate themselves out in the ecological space. So that, I hope that gives you some idea of what we mean by guild structure.
The picture of the 25 ducklings following their mother and father duck, were they of the same species, or maybe 2 or 3 different species? I mean, would you call that dinner?
As far as we're aware, as far as I'm aware, that picture is of all of the same species. Those ducklings, most ducklings are differentiated at the species level. You can tell which duckling belongs to it. All right, but I'm sure that there is some nice technical term that we can come up with, all right, and that you can find scientific immortality there to think of what would you call an aggregation of ducklings, okay? What is a duckling in German? All right. Yeah. What is it? Yeah. And an Entergarten. Okay.
And they are of different sizes as well.
Yeah. Yeah. And yeah, barn owls and things like that. But the thing that's striking about that photograph is that most of those ducklings are about the same size. You don't get that beautiful change in size. Yeah. Yeah. John. Well, I can give you some ideas. I'm sure John has others, okay? Believe it or not, those bottles of red wine lead to differences of opinion. Now, one of the things I found in scratching around in this project is I've been amazed at some of the work that's been done on the sounds that are generated by thunderstorms, for example. All right, there are extremely low frequency sounds generated by thunderstorms, and they, because of the extremely long wavelengths, they actually travel huge distances. And again, I mean, it's a lot of this research that I've been finding along the way is a bit dated, and I haven't found, and I think it's just because of the way research was done in the day. But in the late 70s, I think it was, somebody was studying hearing in birds, and the best bird to use was a domestic pigeon, because you could train it to do certain things when it heard certain frequencies. You can train the bird. Anyway, they discovered that these birds can hear down to a frequency of 1 hertz. 1 hertz. I can't remember how big a 1 hertz wave is, but we're talking about a wave that is kilometers long. Right? It can hear that. So I think that one of the things is that these birds there may be auditory clues as to how far away the water is, or the thunderstorms are, and how the scale of the thunderstorms, right? Because many of our rainfall events are driven by thunderstorms. There are others where there's clear evidence that things like European swifts, right, and many of these other northern hemisphere migrants, they follow those rain fronts. And there's no reason that these waterfowl and other water birds will do the same thing. As these massive rain fronts cross the Zambezi, everybody's sitting down there in the bottom of their little swamp thinking, you know what, I need a really good feed. I hope it rains really hard. And because they can fly relatively long distances quickly and return, the risk involved in those exploratory things are quite low. Then the question, then you come up with the next question is, does, like this exploratory duck, let's call him Fred. Fred just goes off, all right? And when Fred doesn't come back, is that a cue to the other ducks in the system to move as well? Because either Fred's dead, all right, or Fred's there feeding. So then somebody else goes out and checks it out. And if they don't come back, we don't know, but we can conjecture all of those sorts of things. Have you got any other? I mean, the big rain fronts. Sorry? Atmospheric pressure, there's definitely evidence in insects, for example, that they respond very, very rapidly to atmospheric pressure changes. We know this from studies on butterflies, for example. On a sunny day, you can watch butterflies flying all over the place. The minute the atmospheric pressure changes that presages a big thunderstorm or a rainstorm, they're gone. So we know that organisms are pressure sensitive. Certainly, that could be one. The other one that is discussed in quite a lot of detail is, this is not in wetland birds, but in other bird species, is at night we can see thunderstorms. I mean, you've all been in the desert when there's a big thunderstorm in the Khomas Hochland somewhere, all right? And that thunderstorm, we can see thunderstorms 100 kilometers away. Birds see in a different spectral band to us, all right? So how far can they see? We don't know, because I don't know that many people have done any studies on this sort of stuff. But we also know that as soon as you go up a little bit, you can see even further. So without risking a lot, these birds are able to see, like there are many, many clues and cues as to what's going on well away from you. what they're using and whether they're only using one or a whole range or every single one of those cues, we don't know. But John, if you have nothing to do,
Yeah, if I was a betting man, I would bet a lot of money on birds at least having lots of exploratory flights. You know, we might see that there's a thunderstorm over the Hoogland, but we don't know if it's rained, and you wouldn't know how much it's rained, and so on. And so there's lots and lots of scope for, you know, birds making mistakes, and certainly those mistakes would be significant if they didn't have an option to come back quickly. So my speculation is that there are lots more. And it's really hard, as you can imagine, for anybody to pick up an exploratory flight, you know, to see that this individual's gone off there, come back, you know, and to relate that to the sort of conditions that that bird found there. And then also, you know, as I alluded to earlier, you know, what sort of communication might there be between that explorer and the rest of the mob. There's also evidence in, you know, various animals that they pick up. They respond to the scent of smell. I forget the technical term for it. Petrichor, yeah. And that, you know, those are scents that can travel very far. And, you know, just to come back to Chris's point about how lots of migrants, and they're not only migrants, you know, resident birds that are normally in southern Africa, how they follow these rain fronts. You have a lot of young birds, young raptors, for example, that only settle down to breed 2 or 3 years or later in life. They spend a lot of time following rain fronts. Hanyu and I are tracking a Wahlberg's eagle at the moment that spent our winter up in Chad. And as it came back to Witvlei, where it breeds, you could easily visualize from its movements that it was probably stopping in at various termite emergences, and especially in Angola. It went rapidly across the DRC, but in Angola, you could almost pick it up, you know, how this bird was going from left to right and you know, dallying before eventually coming home rather rapidly. None of this is really satisfactory, lots of speculation, but I think we're starting to get to a better feel, at least, for the things that are possible and likely, and it'll be some years again. The youngsters here, please rally and sort out these questions so that we can retire.
I just want to go to a thing that John just said about the exploratory flights, and something he said about the bees as well. There may be a whole system that we don't even understand, where the exploratory flights, Fred goes out there and he sees, man, there is water available. But Fred knows he's got to actually reproduce. So he goes back to his perennial wetland system and does finds his mate there, and then brings her back to that wetland at the critical time. Because as John was saying, you know, if you need to have some cover in which to go and make your nest, you better have cover, you know, you better have good cover. But it's not going to happen immediately. So you've got to wait like 10 days, 2 weeks before you get the grass cover that you need. So, you know, there's no reason why not to go back to your perennial wetland system and then come back. And that breeding behavior within the assembled throng of all the other birds of your own species will then become a key indicator that, yes, Fred knows. So how the information is transferred, I mean, this is pure conjecture, okay? But how the information is transferred between individuals, because it must be, is a fascinating idea and question.
It's a really fascinating little observation that's come up a few times in the WhatsApp birding group. Golden bishops are pitching up on little plays, all sorts of places where they wouldn't normally be. Now, they wouldn't, you know, for a pond outside of Toronto to have enough grass, water and grass for golden bishop to find that useful. That takes some weeks. It's got to rain, and then the grass must grow, and only then will it be appropriate for the. I don't need to repeat that, I'm sure. Anyway, these golden bishops and how they move in, and we've seen that this year, clearly there are lag effects. It rains, and only several weeks later, do things like, golden bishops pitch up there where the grass is long enough for them to feed and to nest and so on.
Thank you very much. I just want to mention that on a smaller scale, we noticed and observed in the Orongo Mountains with two species, that is blacksmith plover and Egyptian goose, that they arrived at a place where they regularly come during the rains, and they arrived there already in December. Checked out, there was no water. Then when they arrived, we thought, okay, they know more than we know, the rain will come soon. But the rain did not come, so they went back. And this happened 2 or 3 times until, as the rain started very late this year, that actually now they are breeding. So just to add to this explanatory journeys, maybe that helps a little bit. Thank you.
But the interesting thing is it requires not only those birds to do that, but somebody like you to see them. And that's, that's rare that you can combine this information, and it's, it's really.
More questions?
So we got one more question. Any millionaires in the?
Leave our email addresses if you want.
Okay, yeah. Thanks, John. Thanks, Chris. That was really good, really interesting. Yeah, and if anybody does have a spare million lying around, please, we need to look at this. I've had the privilege as well to have worked in that Panikkiesveld, as it's called, for quite a couple of years, and it really is spectacular. If the pans have water, it's just like paradise. It's unbelievable. Yeah, and so it would be really good if we could do some more work there, and yeah, before these 2 old toppies here pass away, that they can rest peacefully. Well, just for your information, I took over his job.